Hi everyone, and welcome to another one of my videos. This is a help video for Booklet 11H, and as you can see it's a calculator paper, and that means that you can use a calculator on any question that you like. Don't feel embarrassed that you're using a calculator. As I said before, you don't get any more marks for not using a calculator. You just make more mistakes and take more time. Make sure though that you show the steps in your working. A temptation when you're using a calculator is to do everything on the calculator and just write down the final answer. And that's a good way to lose marks. So make sure that you write down your steps as you go along. Now, the purpose of this video, we've said it before, is to give you a hand on questions where you are stuck. If you're like me, there might not be someone, like me when I was your age, that is, there might not be someone at home who can help you with the maths, even though they're lovely mums and dads, just like mine were. They might not be able to help you. There might not be anybody at home who can help you. So I make these videos to give you a hand on any question where you're stuck. And the best way to use the video is to try your best on all the questions as you can, first of all, without any help. And then you try and use the video to do a few more questions and get your mark bumped up a little bit more. If you're not sure about anything I say in this video, if you're still stuck after having watched the video, then of course please ask me in lessons or outside of lessons and I'll be happy to give you a hand. Okay, let's look at this question. Now, the first few questions are questions that are on the foundation paper as well as the higher paper. But that doesn't mean that they're easy, and we got to make sure that we don't lose any marks. So this question here could be a little bit tricky. We've got 100 adults, and they were asked how they keep fit. Each adult goes to the gym or runs or cycles. 45 of these adults are female. 30 of the 52 adults who go to the gym are female. 35 adults run. 9 men cycle. How many females run? Now, it's difficult to make a start with this because you've got numbers all over the place, and you've got some cycling, some are men, some are women, and what have you. So what I'd recommend you do is draw up what's called a two-way table. So for example, on the columns, we could have gym, run, or cycles. So gym, column, run, column, cycle. And then on the rows, you would have men, a row for men, a row for females, and then a row for all the adults here, the total of the men and the women. If you draw that table out, and then put this information into the table, then it will start to make sense and you'll be able to see what you need to add or subtract to get the answer that you need. Trust me, drawing out a table first of all and putting this information into the table will help you be able to see what it is you've got and what you need to work out. Question 2. On a school trip, the ratio of the number of teachers to the number of students is 1 to 15. The ratio of the number of male students to the number of female students is 7 to 5. Work out what percentage of all the people on the trip are female students. Give your answer correct to the nearest whole number. So what we need to do is we need to work out how many people on the trip are female, and then we need to work out the total number of people on the trip. Now, we've got the ratio of the number of teachers to the number of students is 15, but the ratio of the number of male students to the number of female students is 7 to 5. Now that creates a bit of a problem, which is maybe what makes this question a little bit tricky. If, say, for example, the ratio of the number of male students to the number of female students was 10 to 5, then 10 to 5 and 10 add 5 makes 15, and we can share that out. So we'd have 1 teacher, 10 male students, and 5 female students, and then it would be fairly easy. But when we share something in a ratio, I'm sure you remember, you add these numbers together. 7 add 5 is 12, and we need to cut this into 12 equal pieces. So what I would recommend you do is multiply these two numbers by 12. So instead of having the ratio of teachers to the number of students being 1 to 15, multiply both these numbers by 12. So you'll have 12 to 12 times 15, which is 180. I think it is 180. So why have we done that? Because then you can split that number, that 180, in the ratio 7 to 5. Okay, so instead of writing the ratio as 1 to 15, you write it as 12 to 180. It's the same ratio, it's an equivalent ratio, but it means then that you can split that 180 in the ratio 7 to 5. Okay, once you've done that, you will have 12 teachers and this number, so you'll have a number of male students and a number of female students. That will get you some marks. The percentage of all the people on the trip who are female will be the number who are female on the top of your fraction divided by the total number of people who are on the trip, which will be 12 teachers and 180 students. So what's that? 192. And then you multiply that, or divide the top number, the numerator, by the denominator, multiply it by 100, and you get your percentage. In the space below, use ruler and compasses to construct the perpendicular bisector of the line AB. Now, if you go to Google or YouTube and ask how to draw a perpendicular bisector, it will show you. But I will show you anyhow. The perpendicular bisector, what does that mean? Bisect means cut into two pieces. Perpendicular means at right angles. So a wall is perpendicular to the floor and the ceiling. Two sides of a square or a rectangle are perpendicular to each other. So basically what you need to do is use compasses to draw a line that cuts this in half and at right angles. So cutting it in half is not enough. It needs to be in half and with a right angle. So it needs to be something like that looks like this. Now it's really important that you use ruler and compasses to do this. So you're not going to use an angle measurer to draw a 90-degree line. How are you going to do it? You get your compass point and you put it here, and you open up your compass to beyond halfway. I'd say to about here. Okay, just about there roughly. It doesn't matter, but it has to be beyond halfway. Why? Because you're going to draw an arc, part of a circle that's going to look like that. And then without changing your compass, you're going to do exactly the same thing from here, and you'll get another arc. Now, where those two arcs meet, join them up. So the two arcs will join up there, roughly, and there, roughly. And then you draw a line that goes right through those two dots and out the other side. And that will give you the perpendicular bisector. Question 4. Here is the graph of y equals x squared minus 2x minus 4. So that's nice because they've drawn the graph for us already. And we don't need to draw that and work out the points. It's done for us already. What do they want us to do? Write down estimates for the roots of x squared minus 2x minus 4 equals 0. So, it's no surprise or no coincidence that this expression here is exactly the same as this one here. Now, if it said, write down estimates for the roots of x squared minus 2x minus 4 equals 2, say, we're basically saying, when does this graph equal 2? So we go to 2, and we read across, and we read down. We go to 2, we read across, and we read down. And we read down what these numbers are here. If I said x squared minus 2x minus 4 equals 1, you'd find 1, you'd read across, and you'd read down. You'd read across, and you'd read down. So what does it mean when it says estimates for the roots of x squared minus 2x minus 4 equals 0? I've shown you how to do 1. I've shown you how to do 2. Now you do 0. You need two answers. One will be positive and one will be negative in this particular case. Not always, but in this particular case. Okay, question 5 says the diagram shows a cycle track. Each track has two straight edges or sides, each of length 40 meters, and each end of the track is a semicircle of radius 27 meters. The diameter of each wheel of Ian's bike is 590 millimeters. Ian is going to ride his bike around the track once. Calculate how many complete revolutions each wheel of his bike will make. So let's just get an idea of what that means. Just ignore the numbers first of all. Let's imagine, make some easy numbers. Now, let's imagine the distance round here was 1,000 meters. Just imagine, to make the maths easy. Let's imagine the distance round Ian's bike, the circumference of the wheel, was 1 meter. That means every time the wheel rotates once, he will have gone forward 1 meter. So if this was 1,000 meters and the distance round his wheel was 1 meter, 1,000 divided by 1 means 1,000, which means the wheel would go round 1,000 times. When it goes round once, it goes forward a meter. So to go forward round 1,000 meters, the wheel would need to go round 1,000 times. So the two bits of information we need to work out are, number one, what's the perimeter of this whole shape? And number two, what's the perimeter or the circumference of his wheel? So let's look at the perimeter of the track. You've got 40 here and you've got 40 here. Then we've got this curved bit. We've got a curved bit there and a curved bit there. Can you see that together that and that make what? What do they make when you put them together? How would you work out, using your circle formulas, what this distance is here and here, using this radius? Think about what the formula is to work out an important part of the circle. Is it circumference or is it area? Find the right formula. So you should be able to work out what the distance is around the outside of this track, making sure that you don't, of course, add these dotted lines because they're not part of the track outside. So that gives you one answer, and you'll get marks for that. Now we're told the diameter of each wheel of Ian's bike is 590 millimeters. Now what do you think you should do if that's in millimeters and this is in meters? What do you think you need to do with this number? As a hint, there are 1,000 millimeters in a meter. So how are you going to use that information? The diameter is that. How are you going to then work out the circumference of his wheel? What formula will you use? Hopefully the same formula as you used here and here, same formula. So at the end of your work, you will have calculated what the distance is round the outside of the track and what the distance is round the outside of his wheel. Using those numbers in the way I described right at the very start, you should be able to now calculate how many complete revolutions each wheel of his bike will make. Question 6. The front elevation and the plan of a solid are shown on the grid. On the grid, draw the side elevation from the direction of the arrow. So there's a 3D object. If you look at it from the side, or from the front, to beg your pardon, you'd see this. This is what you would see of this object if you looked at it from the side. If you look down on it, you would see this. So the question is, what would you see if you looked in this direction? Now, don't just draw any shape, make it accurate. Draw it the right number of squares. How wide would it be? How long would it be? How tall would it be? Draw what you would see. Question 7. The distance from the Earth to the Sun is 1.496 times 10 to the 11 meters, and the speed of light is 3 times 10 to the 8 meters per second. Show that, correct the three significant figures, light will take 0.139 hours to travel from the Sun to the Earth. So, how do we work out time? You should hopefully know that speed is distance divided by time. Put that in your formula triangle. Remember, the triangle that looks like we've done for trigonometry. So speed, distance divided by time. That will give you the formula to work out time. Why are we working out time? Because it says, show that correct to 3 significant figures, light will take 0.139 hours. So it's time we're working out to travel from the sun to the earth. How do we work out time? Work it out. But you've got a distance and you've got speed. So you have to work out what you're going to do with those numbers to work out time. If you're not sure, if you're still not sure of that situation, here's another way of working out what you do. What if I said the distance is 100 miles and the speed is 50 miles an hour? How long would it take? And then ask yourself, what did you do with 150 to get that answer? Whatever you did, that's what you always have to do. And so do it with the distance and the speed. The only difference is these numbers look horrible. They're in standard form, but you're still going to do the same thing. And you'll use a calculator. Now, if you don't know how to put numbers into standard form and calculate with numbers in standard form on a calculator, let me know and I'll show you how to do it. Now, doing that and getting that answer and writing it down will probably get you 2 marks. But the question says 0.139 hours. So, what needs to change? Well, if the distance is in meters and the speed of light is 3 times 10 to the power of 8 meters per second, then your time is going to be in seconds. How will you change that time that's in seconds into hours? As a hint, turn it into minutes and then into hours. Question 7. 1 Google is 1 times 10 to the power of 100. Ganesh says, when I multiply 1.496 times 10 to the power of 11 by 6.68 times 10 to the power of 9, I nearly get 1 Google because, and here's his reasoning. Is he correct? Give a reason for your answer. So think about this bit here. This is the bit here. Have a look at that. If you're not sure, what would 10 squared times 10 cubed be? What do you do with those powers when you multiply? Question 8. Find an equation of the straight line with gradient 3 that passes through point A. Now, if it goes through, there's 2 ways of doing it. If it has a gradient of 3, then it means that what? If you have a line y equals 2x plus 4, what's the gradient of that line? If you have a line that says y equals 7x minus 6, what's the gradient of that line? Hopefully, you know that the x number is the gradient. So y equals 2x has a gradient of 2. Y equals 2x plus 6 has a gradient of 2. Y equals 2x minus 7 has a gradient of 2. It's the x number and just the x number that tells you the gradient. So, y equals 3x would have a gradient of 3. It has to travel through that point there. So y equals 3x plus what would make it travel through there? Here's a hint. If it was just y equals 3x, then it would go through that point. 3 times nothing is nothing. When x is 1, 3 times 1 is 3. When x is 2, 3 times 2 is 6. So y equals 3x would travel through there, there, and there. But when x is 2, it's not 6, it's 5. So, what must the equation of the line be? Natasha pays £13,995 for a car. Lauren pays £14,495 for a car. Assume that the rate of depreciation for Natasha's car is 12% per annum, and the rate of depreciation for Lauren's car is 13% per annum. Work out whose car will have the greater value at the end of 3 years. You must show all your working. So it's really important that we show our working out. Now we can see that Natasha's car isn't as expensive as Lauren's when they pay for it. But Lauren's car is losing value faster. It's losing 13% every year. That's what per annum means. And the rate of depreciation for Natasha's car is 12% annum. So it's losing 12% every year. What we don't want to do, because it takes too long, is find 12% of this and then take it off, and then find 12% of that and take it off. What we're going to do is this. First of all, I'll do Natasha's car, you do Lauren. If 12% comes off, if we lose 12%, then what percentage is left? 88. So another way of saying this is, rather than saying it loses 12% of its value every year, we could just say every year her car is going to be worth 88% of what it was the year before. It's exactly the same thing. How do we find 88% of something? We multiply by 0.88. So multiplying by 0.88 reduces the value by 12% because we're just finding 88% of it. Okay, but it's going to be after 3 years. So we take this value, we multiply it by 0.88 for the first year, and then by 0.88 for the second year, and then 0.88 for the fourth year. There's a button on your calculator that will make that quicker. And that will tell you what her car is worth. This car, well, you can work out in the same way what you're going to do for Lauren's car at 13% per annum. And then you're going to work out what it will be 3 years. And then you can tell me which has got the highest value. Question 10. The scatter graph shows information about 10 adult snakes of the same type. It shows the length and weight of each snake. I'm just going to make this a little bit smaller so we can just see it. Right. Then it says the adult snake of this type. An adult snake of this type has a weight of 740 grams. Use the scatter graph to estimate the length of this snake. So here's the weight, and here's the length, and here are different snakes, and they're all adults. And we've got one that is that weight, and this one has that length. And as you can see, there's a trend, there's a relationship between the weight of the snake and the longer it is. So basically, the bigger it is, the longer it is, and the heavier it is. So here's a small snake that doesn't weigh very much, and it's not very long. And here's another snake that is longer and it weighs more, and that makes sense. But it's not exact, because snakes come in different shapes and sizes slightly, just like people do. So just because you're taller or longer doesn't mean you're heavier. Not always. So it's not an exact relationship. It's not in a straight line. So the first thing we need to do is draw as best as possible a line of best fit. Don't just do this by eye and answer this. Draw yourself a line of best fit. And then use the line of best fit to work out what the length would be. So for example, if it said a weight of, let's say it had a weight of 640, I find 640, I go to the line, which will probably be about there, make sure you draw the line, and read down, and it will be about 65. And you do the same thing for 740. Then it says Stephen wants to estimate the weight of an adult snake of length 110. He says he will draw a line of best fit and read off the weight at 110 centimeters. Okay, explain what is wrong with his method. So let's just go back to that question and have a look at this. Right. So the length, he wants to estimate the length here. Now, what could be wrong about reading off the weight and trying to estimate the weight here for 110? Have a think about it. It's fine doing here and here all down to there, but it's less good for 110. Why do you think that might be? Just come up with what you think sounds to be a reasonable answer, a reasonable explanation, and I'm sure you'll be right. Question 11. Write the number 47,805,000 in standard form. You should be able to do that. You just count and move the decimal point back, counting as you go. Factorize x squared minus 121. Now, this is what is called the difference of two squares. And you could search for this on YouTube or one of your favorite math websites. But the key thing about this to spot when you see something like this is that this is a square number. And that's key. And that says negative. Now, if you just get a pair of brackets and write down for me, just do this. X plus 6, x minus 6, and then multiply those two brackets together. Take your time and do that for me. You'll get x times x, x squared, x times 6, 6x, minus 6 times x, minus 6x, minus 6 times 6, minus 36. So you've got here x squared plus 6x minus 6x minus 36. And the key thing there is that you've got a plus 6x and a minus 6x which wipe each other out. So you're not left with any x's. You've just got x squared minus 36. And 36 is a square number. So x squared minus 36 could be factorized or worked backwards to two brackets. And what do we use? X plus 6, x minus 6. In the same way, x minus 7, x plus 7, you could factorize that or expand that, and that would make x squared minus 49. So what would you put in brackets to get x squared minus 121? Question 13. The table shows him information about the weights in kilograms of some boxes. Ben uses the information to draw the box plot below. Okay, well this sounds pretty promising. Let's see what we can do here. So, we've got a minimum. We've got a lower quartile. So this is the minimum. This is the lower quartile. This is the weight, beg your pardon, the median. This is the upper quartile. And this is the maximum. Right. So, write down two things that are wrong. So let's just check. To check these numbers here, do they work out to be right? Okay, this should be the median. This should be the upper quartile. This should be the minimum. This should be the lower quartile. So first of all, I can see a question, a part here that is wrong. There's an answer there that is wrong. And it's just a simple matter of spotting the difference. What is the difference between these numbers here and where they've been plotted here? So there's one mistake. The second thing is this. What's that number there? It's 55. But it says the range is 55. This should be the maximum. So the maximum isn't 55. What should it be? Well, you're told that the range is 55. What does that mean? It's the difference between the biggest number, the maximum number, take away the minimum number. So that means there's a difference of 55 between the minimum and the maximum. So if the minimum is 12, what must the maximum be? It's not going to be that number there. Work out what it is, write it down. Question 14. I would probably ignore that question. Okay, I would probably ignore that question. If you want me to show you that in class, I will. And maybe we'll do it in class because it does figure on the foundation and the higher. But it's difficult for me to show that to you without being able to draw anything. So we'll miss that out. Question 15. Prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. So, what I would do is this. Let's see if we can get some marks. So prove algebraically the difference between the squares of two consecutive integers. Right. So let's start off with n for a number. And consecutive, what does that mean? It's like 1, 2, 3, 4 consecutive numbers. So if you start off with a number, how do you get the next consecutive number? You add 1. So let's start off with our first number and we'll call it n. The second number, what will that be? It will be 1 more. Okay, but it says the squares of any two consecutive integers. So we'll need to square those two expressions. One is going to be easy. It's going to be n squared. The other one is going to be what? Okay, you should have a bracket that's squared. Okay, work out what that is. Expand those two brackets. What do I mean by two brackets? Well, it says something in a bracket squared. So it's bracket times bracket. Work out what that is. Then take away n squared from that. Then think about how that proves it's always going to be an odd number. Now you might not get to the end, but you might be able to pick up some marks. So have a go. Question 16. Describe fully the single transformation that maps M onto triangle N. So what we've got is an enlargement. How do I know it's an enlargement? Well, simple, because if they were the same shape, I'd say it was a rotation. So if, for example, this triangle was only this size, I'd say that was a rotation. This has been rotated to that or the other way around, M to N, from there to there. But it's been made bigger. So the only way we're going to make something bigger is with what's called an enlargement. But the enlargement has moved the shape upside down. Now the way to find the information you need is first of all, to say it's an enlargement, I've told you. Second thing, you need to say what the scale factor is, basically how many times bigger it is. And secondly, where the center of enlargement is. And the way to find the center of enlargement is simply to join up corresponding corners. So this corner corresponds to that corner. Join it up with a line. This corner, where does that corner correspond to on this triangle? Which is the corner on this triangle that corresponds to this corner on this triangle? Join them up with a line. Where is the corner on this triangle? Where is the corresponding corner on this triangle? Join those up with a line. If you've done it right, all three lines should cross at the same place. That's what's called the center of enlargement. Say center of enlargement at, and then write down the coordinate of that point. If the shape is the same direction, or the same size, beg your pardon, let's start again. If the shape is just an enlargement and it is the same orientation, then it will be a positive. If it's upside down, it will be negative. So if this triangle was 3 times bigger than this, and say, for example, somewhere up here, we'd say it's a scale factor of 3. But whatever that scale factor is, the shape has become upside down. And also, the shape is on the other side of the center of enlargement. And so it's a negative scale factor. So if it was 3 times bigger and facing up the same way as this triangle, we'd say scale factor 3. If it was facing upside down, we'd say scale factor -3. We'll do a bit more about this in class. Question 17 says the diagram shows Helen's fish tank. All the dimensions are correct to the nearest centimetre. Helen is going to use a bucket to fill the fish tank completely with water. There are 14 litres, correct to the nearest litre, of water in a full bucket. Will 25 buckets of water definitely fill the fish tank? Justify your answer. Now, this looks on the first case, on the first appearance, like a foundation question. If it was a foundation question, it would just say, these are the dimensions, and will 14 litres 25 times fill it? And that would be easy. We'd go 25 times 14. We'd work out what that is in litres. And we'd work out what this is in litres. How do we do that? It's that length times that length times that length. And that gives us our answer in cubic centimetres. which we would need to change into litres. And you remember that 1,000 cubic centimetres is a litre. So you would change that into litres. However, it's not a foundation question. It's a higher question. So we've got to remember that. Now, it tells us the clue is that all the dimensions are correct to the nearest centimetre. So even though that says 120, it might not be 120. It might be a bit more or a bit less. This might be a bit more or a bit less. This might be a bit more or a bit less. And this is 14 litres correct to the nearest litre of water in a full bucket. So, if we want to work out whether that bucket will definitely fill the fish tank, what we need to do is say, okay, well, let's work out what the maximum this volume could possibly be. And let's work out what the smallest this bucket could possibly be. And then if the smallest bucket fills up the biggest tank, then it will definitely fill it up, whatever it is. So, 14 litres correct to the nearest litre. What will that be? What's the biggest it could be? And what's the smallest it could be? What's the biggest that could be without being rounded up to 15 litres? And what's the smallest it could be? What's the smallest that bucket could possibly be without being rounded down to 13 litres? Hopefully you've put down 13.5. If it was less than that, it would get rounded down to 13. But once it's 13.5, it would get rounded up to 14 litres. So actually that bucket could be as small as 13.5. And that's now you need to work out what 25 lots of that would be. Now, this is 120 to the nearest centimetre. What's the biggest it could be? The biggest would be 120.5. What's the biggest that could be? What's the biggest that could be? Use those numbers to work out the biggest the volume could possibly be, and then use your answer here to see if 25 buckets will fill it. If you're not sure, ask me. Question 18. This is starting to get a bit more tricky, but we can do this. T is inversely proportional to the cube of u. Remember what we do. So when u is 5, t is 0.0096. So it says t is inversely proportional to the cube of u. So if it said t is inversely proportional to u, we'd write t equals k over u. But it says the cube of u. So we're going to write t equals k over u. What comes next? Cubed, because it says the cube of u. Right, so we've got the same kind of idea as before, but t equals k over u cubed. And just like before, we need to work out what k must be. Okay, so put in u is 5 and t is 0.0096 into your equation you've just written down there, and use that to work out what the value of k must be. Now you've got your formula, because we did have t equals k over u cubed, but using this information, you should have worked out what k is. Have a go, you'll pick up some marks. Then put this value into your new formula and use it to work out what u must be. Question 19, we can miss that out. Question 20, you can miss that out. Question 21, let's have a quick look at that. You can miss that out. And 22, you can miss that out. 23, you can do that bit there. Work out the value of this when x is 0. Work out the value of this when x is 1. And see how that tells you that it has a solution between 0 and 1. You can miss that out. You can miss that out. 24, you can miss that one out. And 25, I think we can miss that one out as well. Okay, so there's quite a few questions in this booklet that I think we can have a go at. which gives you ample opportunity to get a great mark. It's always difficult to explain things when I can't write. So if you watch the video and you're still not sure about something, please ask me. I will help you, because the higher your mark, the more your confidence will be. And that's what I want. I want you to be confident. Cheers, guys. Thanks a lot. Thank you.